Every single second, Netflix processes over 10 million events. Uber tracks millions of rides in real time. LinkedIn handles trillions of messages every single day. And they all have one thing in common, a technology called Apache Kafka. By the end of this video, you'll understand exactly what Kafka is, why it matters, and how it works, even if you've never written a line of code. Imagine you run a small restaurant. You have one chef and one waiter. A customer walks in, the waiter takes the order, walks to the kitchen, hands it to the chef, waits for the food, and brings it back. Simple, right? Now imagine your restaurant goes viral. Suddenly you have 50 customers, 10 waiters, and 5 chefs. The waiters are tripping over each other. Some orders get lost. The kitchen can't keep up. It's chaos. So what do? You put up an order board. Waiters pin their orders to the board. Chefs pick them up when they're ready. Nobody waits around. Nobody gets blocked. Everything flows. That order board, that's basically what Kafka does for software. In the software world, you have dozens of applications that need to talk to each other. Without something in the middle, you end up with a tangled mess. Kafka sits in the middle. Systems drop messages into Kafka, and other systems pick them up whenever they're ready. So here's the formal definition. Apache Kafka is a distributed event streaming platform. Let's break that down into plain English. Distributed means Kafka doesn't run on a single computer. It runs across multiple machines, so if one goes down, the others keep things running. Event means something that happened. A user signed up. An order was placed. A payment was received. Kafka deals in events, tiny packets of information that say, hey, this thing just happened. Streaming means this happens continuously, in real time. Events flow through Kafka the moment they happen, like a river that never stops. Now here's what makes Kafka special. It plays 3 roles at once. First, it's a messaging system. It moves data from point A to point B, like a postal service for your software. Second, it's a storage system. Unlike a regular message queue where messages disappear once someone reads them, Kafka keeps messages around. You can go back and read yesterday's messages, or last week's, or even last month's. It's like a DVR for your data. Third, it's a processing engine. You can transform, filter, and analyze data as it flows through Kafka in real time. Alright, now let's look at the 5 building blocks of Kafka. I promise to keep this simple. Number 1, topics. A topic is just a category or a label. Think of it like a folder in a filing cabinet. All order-related events go into the orders topic. All payment events go into the payments topic. Producers write events into these topics, and consumers read from them. Number 2, partitions. This is where Kafka gets its speed. Each topic is split into multiple partitions, think of them as lanes on a highway. Instead of all the cars using one lane, you spread them across multiple lanes so traffic moves faster. This lets multiple consumers read from the same topic at the same time, each taking a different partition. More partitions, more parallelism, more speed. One important rule, within a single partition, messages are in strict order. But across different partitions, there's no ordering guarantee. This is a trade-off Kafka makes for speed. Number 3, brokers. A broker is just a Kafka server. In production, you run multiple brokers together, that's called a cluster. Each broker stores some of the data. If one broker crashes, the others still have copies, so nothing is lost. Think of brokers like bank branches. Each branch holds some of the bank's records, but together they have everything. Number 4, producers. A producer is anything that sends events to Kafka. Your mobile app, your website, your payment service, any system that says, hey, something happened, is a producer. Producers decide which topic to send a message to. And if the message has a key, like a customer ID, Kafka guarantees that all messages with the same key always go to the same partition. This is how you keep related events together and in order. Number 5. Consumers and consumer groups. A consumer is anything that reads events from Kafka. But here's the clever part: consumers are organized into groups. Within a group, each partition is assigned to exactly one consumer. They share the workload. But different groups are completely independent. Group A and Group B each get their own copy of every message. This is powerful. Your order processing service and your analytics service can both read from the same topic without interfering with each other. This is fundamentally different from a traditional message queue, where a message disappears once someone reads it. In Kafka, messages stick around. Let's follow a single event through Kafka from start to finish. Step 1. A customer places an order on your website. Your order service, the producer, creates an event. Step 2. The producer sends this event to the order's topic. Kafka looks at the message key, runs it through a formula, and decides which partition it belongs in. Step 3. Kafka writes the event and gives it an offset, a unique number, like a ticket number at the deli counter. Step 4. Kafka copies the event to 2 other brokers for safety. This is called replication. If the main broker crashes, one of the copies takes over. Step 5. Multiple consumers pick up the event. The email service sends a confirmation. The analytics service updates the dashboard. The inventory service reduces stock. Each is a different consumer group, reading the same event independently. And that event stays in Kafka for as long as you configure, days, weeks, even forever. Kafka can handle millions of messages per second. How does it do it? Most people think writing to disk is slow. But Kafka writes sequentially, it just keeps appending to the end of a file. Sequential disk writes are incredibly fast, sometimes faster than random memory access. Second, Kafka uses zero-copy transfer. It tells the operating system to send data directly from the disk to the network socket. No unnecessary copying. Third, batching. Instead of sending one message at a time, Kafka groups messages into batches. It's like shipping 100 packages in one truck instead of sending 100 individual couriers. And fourth, compression. Kafka compresses batches of messages, reducing the data that travels over the network. Put it all together, and Kafka achieves throughput that's orders of magnitude higher than traditional message queues. Let's look at 5 real-world use cases. Number 1, real-time recommendations. Netflix uses Kafka to track what you watch, what you pause, what you skip, all in real time. That data flows into their recommendation engine, updating your homepage within seconds. Number 2, ride tracking. Uber uses Kafka to process location updates from millions of drivers and riders simultaneously. Every GPS ping flows through Kafka. Number 3, fraud detection. Banks use Kafka to analyze transactions as they happen. If your credit card is used in New York and then Tokyo 5 minutes later, a Kafka-powered system flags it instantly. Number 4, data synchronization. Companies use Kafka to keep multiple databases in sync using change data capture. Number 5, IoT and sensor data. Factories, smart homes, and connected vehicles generate massive streams of sensor data. Kafka ingests all of it and feeds it to monitoring dashboards. Kafka isn't just one tool. It comes with a whole ecosystem. First, Kafka Connect. This is a plug-and-play framework for moving data in and out of Kafka without writing code. Hundreds of pre-built connectors exist for databases, cloud storage, search engines, and more. Second, Kafka Streams. This is a library for processing data inside Kafka in real time. You can filter, transform, join, and aggregate streams of events, all within your application. Third, Schema Registry. As your data evolves, Schema Registry makes sure old and new versions play nicely together. It's like a contract between producers and consumers. So when should you use Kafka? Use Kafka when you need high throughput, millions of events per second. When you need to replay historical data. When multiple services need to consume the same events independently. But Kafka isn't the answer to everything. If you just need a simple task queue, RabbitMQ or Redis might be simpler. If your data volume is small, Kafka's operational complexity isn't worth it. It's all about picking the right tool for the right job. And that's Apache Kafka, a distributed event streaming platform that acts as the central nervous system for modern software. Producers send events to topics. Topics are split into partitions for speed. Brokers store the data and replicate it for safety. And consumers read events at their own pace, without affecting each other. If this video helped you understand Kafka, hit the like button and subscribe for more tech explainers. Thanks for watching. I'll see you in the next one.